I'm Simon Wood. I'm a technology director at Holiday Extras, and I've been doing sort of web development for about 18 years in a commercial capacity now, and in the last 5 years, most of that has been doing APIs in the travel industry. So the company I work for is it's Time Top 100 company to work for. We came 10th this year in the Times Top 100, and we're a sort of 32-year-old business. We do airport add-ons, so we do airport car parking, airport hotels. And the section of the business I work in is doing e-commerce platforms for the UK theme parks. So we underpin most of the UK's major theme parks, building their tech platform, generally API-based, and delivering hotels in the UK with tickets into theme parks like Legoland. Now, as well as my role at Holiday Extras, I'm also an advisor for a startup called MyDrive, and we were very fortunate last week to just close a Series A round of funding. And we're trying to change the learn-to-drive industry in the UK through the application of technology. And all the work we've done at MyDrive has been API first. So we built an API, we built all the logic into the API, and then we've built very lightweight mobile and web apps based off of that. So moving on from me and getting down to what we're going to cover today, the talk's broadly going to be split into two main sections. So firstly, covering consumer debugging. So for those of you that are using APIs, tools and applications you can take to making consumer debugging easier. Then I want to move on to debugging from an author's perspective and some of the techniques we can use there. And then lastly, going through the considerations that API authors should be having to try and make their lives easier for those that are consuming their APIs. Now, I'm fortunate that this talk follows on from Kirsten's talk yesterday, as she's covered some of this stuff in her talk, and it should lead on nicely. So we're going to kick off with the sort of consumer debugging. Those of us that are sort of trying to enrich our applications, enrich what we're doing on the web through using other people's APIs. And the hardest part here, really, the whole debugging story starts with the selection process. So when we come to select an API, this goes on to have lasting effects on how we go about debugging it. Depending on what APIs we choose and depending on what their communities are like and how rich and helpful their communities are or how good their documentation is, can really affect how we go about debugging the problems we're likely to encounter. And in this selection process, there's a sort of discovery phase. So I want to go and use an API. Which API should I use? Now, there's some help out there. We've got things like Programmable Web and Misshapes and APIs.io. These are tools that allow us to, work out that we want a telephony API, so we go and find Twilio, or we want a weather API. But we need to go further, and we need to sort of think of it more in the way that we would choose libraries and frameworks. So we need to select APIs that have a rich community and ask those around us, be looking on Twitter, be looking on the other channels we have to find which APIs are best going to support us. Now, when we're selecting APIs, I like to sort of really harp on quite a bit about this idea of microservices. So I'm not a fan of big, large tech stacks that do everything in one code base. I believe we should be picking small, discrete APIs that do one thing and do it really, really well. We can then combine these APIs to actually fulfill the service we're trying to fulfill. But through microservices, I think this will make our lives easier to debug. We can pick APIs based on their strengths, and then we've only got smaller components to pick through and debug. Now, as we integrate these microservices, we should be looking for abstraction. So this is something I learned while working on MyDrive. With MyDrive, part of the function of the product is that you can track a driving lesson. So you can start a GPS function, and then you can track that drive. And when we store that drive, we lock away the weather that happened when you were out driving. Now, we chose to use the Yahoo Weather API, but in the future, we knew we might change that out for another API. So we abstracted away from the JSON payload that comes back from the Yahoo Weather API, and we formed our own payload of what we think an abstracted weather payload looks like. We then mapped the sort of JSON payload that's coming back from Yahoo Weather to our abstracted payload. And then the advantage there is we can switch out to other weather providers in the future without having to roll out new mobile code bases or new website code bases. So what I'm trying to say here is that we don't want to be locking ourselves into people's APIs, especially if we think there's a risk aspect there due to the API not being either heavily heavily used in the community or being quite a new young API. You know, we could build our whole product up on a whole suite of APIs only to find some of those are discontinued or change their pricing model. Now, once we're integrated with APIs, and Kirsten touched on this a bit yesterday, we have the issue of version monitoring. So versions of APIs will change, and they will break our product. If I'm using Twilio's API, or I'm using Twitter's API, you know, this stuff changes. Twitter made a big change in 2012, and the way that they applied OAuth to their API. So previous to 2012, you could do searches without having to authenticate against the API. Post 2012, you had to authenticate. Now, there were hundreds of Twitter clients out there, desktop and mobile clients, and most of these broke overnight. Now, fortunately, in the last year, we've had this beautiful tool come along called API Changelog. So API Changelog tracks the top 56 APIs, but it's growing every month. And you can go on here, and you can click these follow buttons, and you can subscribe to being updated on changes of public APIs. Now, what happens when you subscribe to these changes is you get a difference match. It's very similar to doing a difference when you're committing your code to Git. All the stuff in green, this is the Twilio API, is additions, and all the stuff in red is the stuff that's being removed. So this is the last change that happened on the Twilio API, and we can clearly see how it's going to affect us. And API changelog actually updates for when changes have been announced, not when changes are rolled out. So we can actually make changes to our code base to adopt the change in version in APIs. Now, one thing I should have said at the start, there's quite a lot of tools and URLs in this talk. Don't worry about trying to track them all down. I will share them all on Twitter afterwards. Now, we've selected our API, and the next challenge that really faces us is networking. So the biggest problem with HTTP and web APIs is that even before we're talking to the API, we have to negotiate the internet. This becomes even more of a problem when we're using private APIs. So in my work at Holiday Extras, we integrate with many hotel APIs. And most of these APIs are not publicly available on the internet. You can't go and browse them or browse their documentation. They are shared with us. We're given an IP address. And more often than not, when we try and connect to that for the first time, we're blocked by the third party's firewall. So, you know, we need to negotiate these network problems and get to the bottom of what's going wrong. And with the connection issue, we've got a lot of tools out there. We've got a lot of tools that have been around for a long time, like Traceroute, and there's more modern versions called MyTraceroute. And there's also, you know, if you're not into using terminal tools, there's some graphical versions. So the guys at Telerik have created an excellent tool called Fiddler, which is a graphical tool for tracing network issues. And if you're on a Mac, then there's HTTP Scoop. Now, I could go into these. There's almost a talk in its own right in these tools. But the DigitalOcean guys have written this excellent blog post on how to use Traceroute and how to use MyTraceroute to diagnose network issues. So again, I will link to this at the end of my slides, and you can go and read about the best way of approaching this problem. Now, I've got across the network. I can now know that I can talk to the server that's running the API, be that a public API or a private API. The next challenge we really face is authentication. So David Zuckerman picked up on this yesterday, and he said that auth is hard, mentioned about them using HMAC instead of OAuth on the API at Wix. And there are so many authentication methods out there. So with APIs, some are using basic auth. We also see a lot of use of OAuth 1 and OAuth 2. And then there's emerging authentication methods like HMAC and Hawk. And again, there's a whole talk in talking about API authentication. But to sort of help you out, the best way as a consumer of an API to sort of overcome these issues is to use a library. So we shouldn't be hand-coding OAuth. You know, there's been a lot of talks on the toolkit track about how to make our developer lives easier and don't make developers cry. You know, you shouldn't be hand-rolling OAuth code. It doesn't really matter what language you're using, be it Ruby or be it using Python or PHP or JavaScript. There are great tools out there for doing OAuth, Hawk, and digest methods of authentication. And if you're not using them, then you're only really causing yourselves more pain. Once we sort of overcome this sort of using a library, then the other thing is really to test in isolation. And I'm going to pick up more on this in a bit, is that quite often we can sit there debugging an API we're consuming when actually the bug is in the code that we're writing to consume that API. So we need to get around that. We need to go directly at the API. We need to talk to the API directly to be sure where the issues are occurring. Now again, the guys at RunScope have put an excellent tool up there whereby if you're trying to talk directly to an API that's OAuth, then they've got this token generation tool where you can generate OAuth 1 and OAuth 2 tokens. So you can fill out your client ID, your secret, and your URL. You hit the go button and it generates you an access token. So if you're going against something like the Twitter API and you're planning on doing it straight on the command line, or you're going at it in a browser and you need an access token, you can generate your access token using this tool and then test the API with direct calls. So as I said, that leads nicely on to direct API calls. Often I've been there scratching my head trying to debug a third-party API like Twilio or Facebook or Twitter, and the bug is in our code, in my own code. So we really need to get away from that. And the benefits of direct API calls is that it's quick, it's quicker to directly call an API and see what's going wrong, it's easier to change gets to posts and retry our requests. And the scope, we narrow the scope of what we're looking at. If we can create less moving parts, this makes all debugging easier, be it we're debugging standard source code or debugging APIs. If we can remove the moving parts, then there's less scope to look at, and this will make our lives easier. So you're sold on the idea of doing direct API calls, but what can we use to do it? Now, some of us start out using the browser, and the browser can be a good tool for testing APIs. But the browser introduces a unique set of problems. So it's quite hard to do put and delete requests in the browser. And there are other aspects like the auth that are difficult to do if you're using the browser to test APIs. So those of us that are comfortable with the terminal, we fall back on curl. And curl, again, it's a great tool. If you're comfortable in the terminal and you know your way around the curl syntax, then this is a good way to test APIs. But there is a deep syntax to learn, and if you've ever seen the curl man page, it goes on for several pages. So the tool that I prefer to use, and one that I think all API consumers and API developers should be using, is Postman. Now, Postman's a free tool. It also has a premium version with more features, but you get it from the Chrome Web Store, and you can download it. It's highly recommended by many of those using APIs, and people like Twilio on their own API documentation mention using tools like this to test against their API. And when you dig more into Postman, then what you can see is up here we can put in a URL, we can change to get, post, put, and delete requests, we can change the character encoding. Most of the auth is baked in, so it's very easy to do authentication here. And then as we play a request and send a request off, we get a history down the left-hand side. This is almost like a web browser is to HTML pages, Postman is to APIs. And if you struggle to get anything else from my talk today, but you are consuming APIs, I strongly, strongly encourage you to go and download Postman, as it will make your lives a lot easier. Now, we've negotiated the network, we've negotiated the auth. We're now onto this unique area of dealing with the payload. And the payload is a hard one to debug, but again, there's an emerging set of tools that have come about in the last few years that allow us to look at this from a different angle. And I want to take some time to talk to you about mocking APIs. So, from a consumer perspective, having a mocked API gives us a sort of stable set we can look at. And also, if we're in an environment where, like at my company, we're developing an API and we've got another team consuming that API, then sometimes those things are trying to happen in parallel. And Ryan Abel covered this really well when he said that developing an application and an API in parallel can be quite the tricky task. He goes on to say, often at times it can lead to misunderstandings and miscommunications between developers. This can cause projects to progress to come to a screeching halt, and the longer the misconceptions go unnoticed, the bigger the damage may be. And he's really onto something here, and again, he's got a great blog post on mocking and faking APIs. And so, if we use mock APIs, then it helps us out with the schema. So when we talk about API payload, the most important thing is the schema we're using to return our JSON or our XML. And if we're using a mock API, then we tend to have these discussions about schema up front. So if we've got an internal dev team, like myself, where we're building an API and consuming an API, if we're going to mock it, then those two teams come together. An agreement's made up front and a contract is formed. And this helps because the architecture gets discussed up front. The consuming team, if they have an issue with something like pagination or auth, this discussion happens earlier on. And the problems are resolved so that we can move on and both work independently. Change is sort of mitigated. So we talked earlier about API changelog, where we can see when there's changes on APIs. Now, if we're using a mock API, we don't have to worry about changes on the APIs. We've locked the state down at a specific period in time. And we haven't got a mobile app team working against an API like the Twitter API that's constantly pushing us to the new version. And while they're developing, they're spending every day scratching their head over changes. They can lock down the API at the start of their mobile development. They can develop against a mock of the API. And then when they come to the end of their project, they can update to the latest API and do any necessary changes that have occurred between those times. Now, another great one, and the Twitter API comes to mind, is rate limiting. So if you do searches on the Twitter API, you can only do 1,000 searches an hour. Now, if I'm building the latest, greatest TweetDeck or Twitter API, client on my mobile phone, I'm soon going to hit these rate limits in my development process. And if we use mock APIs, then we overcome these rate limits. And then the last real big selling point I have for mock APIs is the efficiency. So back to Ryan Abel's quote, if internally you have a dev team building APIs and then you've got another team, possibly not even internally, remotely somewhere else around the world consuming those APIs, those teams can work in parallel. By the client-side team or the mobile team working against a mock API, those two teams can work in parallel and then resolve the few issues that happen at the end. And therefore, this is sort of a lot more lean, it's a lot more efficient. We can deliver projects earlier and therefore get a sooner return on investment. So again, possibly I've sold you on the idea of mock APIs and you're wondering how to go about it. And again, sort of a nice blend between the tooling track and the API track is that we've got a lot of tools out there to help us. So Mockable.io is a tool where we can put a payload of JSON data against a URL, and then we can call that URL from anywhere we want, any mobile app or web app. Apery also have a tool. So Kirsten mentioned yesterday Apery. They have a tool that works very similar. And Mocky, my own sort of personal favorite, again, is a very simple tool. We can put in JSON payloads and get a URL to start calling those payloads from. So a little demonstration of this, if I go to Mocky.io, we can put in a JSON payload, we can define a status code, we can define if it's application JSON or XML, what character set we want. We hit generate my response, and we get a unique URL. And this URL we can go and program against. So you can go and build a Cordova app or a native iOS app or go and build a Backbone or Angular app, and you can talk to these URLs. Now there's a few problems with mock APIs, and that leads on to fake APIs. So mock APIs are great if you've got an internet connection, but with fake APIs, these can work offline. So if you're about to go and jump on a 7-hour flight and you want to build your next greatest Angular app against, again, the Twitter API, having a link to Mocky.io isn't really going to help you out with no internet connection. Now, fake APIs, they run on your own machine. They run on localhost, and so you can program against them wherever you are, be it sitting in a beach in Brazil or taking a flight across the Atlantic. And again, you might think these are edge cases, but we had an example in our team recently. So one of my front-end developers was going to a theme park to actually talk to customers about our website. So we actually wanted to get first-party feedback. And we couldn't be guaranteed a good internet connection at that theme park. Now, our travel websites are all API-based, so the front end is either client-side JavaScript written in Backbone, or we're doing server-side rendering in Node talking to an API. So the developer in question had the web stack running on his laptop, but the API he wanted to talk to, he didn't have, and he didn't have an internet connection. So we could very easily, with fake APIs, bring this across to his laptop and have the API snapshotted for him to then show a working website to the customer. Another thing, and it might not affect all of you, but it affects us again, is this aspect of security. So if we want to test with real data, we might be building a payment API. We possibly don't want to go and put some payment details into Mocky.io where anyone can scrape the URL and see the payloads of data. So there's advantages to security by using fake APIs and hosting these payloads locally. Also, we do a lot of hotel integrations, as I mentioned earlier. So we do a lot of talking to hotel suppliers' APIs. And if we're testing our web stack and we're making bookings, they don't want us to be consuming room nights in their hotel or taking up reservations. They don't want us taking that stock away from their customers and our own customers. So by using a fake API, when we go to test a booking request against our API, we're not actually taking stock off sale. And there's many advantages to that. And then mocking APIs. So if I'm back to using Mocky.io and I put a nice little payload of data up that returns 5 books, and then I do a put request to insert a new book, if I go and call it again, I still only get back 5 books. But the fake API technologies I'm about to tell you about, most of these allow you to see those put requests or delete requests and actually alter the JSON payload you're returning. So for all intensive purposes, they look like a real API. They behave like a real API, but you're just not running the business logic in the background. So there's sort of 3 great tools out there I've played with, Dyson, JSON Server, and Interfake. They all work roughly the same way. Thanks to Rob's talk today, covering the fact that everyone apart from one has got NPM installed on their machine, you'll all find it very easy to get these up and running. They're all node-based, they're all hosted on GitHub, and you can install them all with NPM. Most of these are quite new open source projects. Many of them are looking for contributors and people to help them grow, so I encourage you to look into them. And then to take Interfake as an example, I can get up and running within about a minute or 2. So we can do npm install, we can write 4 lines, so we include Interfake, we new up an Interfake, we do Interfake get, we register a route, so we register what's next, we return a payload of JSON data, and then we fire up port 3000 and listen out. And now we can open curl or Postman or our browser, and we can go to localhost 3000, what's next, and we get a payload of data. And we could be doing FS stuff on the 3rd line here, so we could be reading static JSON files off disk or off an S3 bucket. So very quickly, we can take a snapshot of a public API, and then we can fire that up. We can almost stub that up to build our client-side application against. Now, the other great thing about debugging payload is the idea of proxying. So sometimes we've already got an established mobile app out in the wild, and we might have an established API which it's talking to and consuming. And we want to sort of sit in the middle and spy on what's going on. We want to sort of snoop on the packets of data that are going backwards and forwards. And with proxies, we can do this. So we can sit between the client-side code, we can sit between the mobile app and the server-side code, and we can snoop on the data going backwards and forwards. We can snoop on the headers. And in many of the tools I'm going to tell you for proxying, we can actually start to replay this data. So if we sent a request through and it broke, we can change small parts of the payload and hit replay and see what happens. Skipped a bit ahead of there. And this replaying allows us to very quickly diagnose issues. Also, with some of these proxies, we can tunnel. So if I'm using a tool like Interfake, it's on my local host. But now I'm working with a mobile development team halfway around the world, and they want to talk to my local host. And some of the proxying solutions out there allow you to tunnel through and expose an internal API across the internet. So for proxying, we've got Wiretap. So Wiretap is it's like a browser network tab, but for mobile and web apps. It's like Chrome's debug tools, but for APIs. You go in there, you register an API, so you register your own api.domain.com and a root, and it gives you its own path back, which you then consume in your Angular backbone or mobile app, and all traffic will be routed through there. Runscope have a similar tool. So they have a tool called Traffic Inspector, again, which will give you a unique URL to proxy your API calls through, and then you can inspect all the traffic going backwards and forwards over the network. But a tool I'm a big fan of is ngrok. So unlike these other tools, which are hosted services and paid for services, ngrok is an open source project. You can install it on your machine. And with ngrok, you can expose a local API out over a tunnel. So again, it's probably far too much to go into this talk. I link to people who talk about this far better than me afterwards. But we can fire up ngrok, expose a port on our machine as an API, and then as requests are coming backwards and forwards, we can actually browse a traffic inspector in our web browser that shows us all the traffic going up and down. Now, the last point I wanted to make on payloads and debugging payloads is turning off caches. So I've been there hacking away at an API, wondering why nothing's working, only to realize I've wasted half a day because I've got some cache sitting on. I've either got cache in my browser, or I'm running a Redis cache in front of the API. So the first stage of sort of debugging payloads would be to turn that cache off. Make sure you're not wasting your time. Make sure you're going at live data before you waste hours sort of scratching your head. Now, the next area I want to talk about is author debugging. So some of you consuming APIs, and hopefully I've given you some tools that you can use there. But I think as API authors, those of us in the room that are, we have a responsibility to think about debugging too. And I touched on this briefly last year in my talk, but I want to go into this a bit more, which is logging. So although, as a consumer, you can be using these proxy tools, as an API author, you need to log what's going on your API. And you should really be thinking about baking logging in from the start. Logging gives you this audit trail, so it gives you this sort of inventory of everything that's been going on. We can see what's going on our production API, and then we can use that to pinpoint issues. So again, in our business, we have a situation where our APIs are hierarchical. So we have one API that we call into, let's call that api.holidayextras.com, but that's not our only API. Because of microservices, we have many APIs below that we call, so our booking API is independent of our reservations API, is independent of our content API, and then those reservation APIs go down further to talk to third-party hotels APIs. And when things go wrong, we need to identify which level of the stack it's gone wrong at. So with this sort of using logging and using logging across our APIs, we're able to pinpoint where the issues occur. We do something that many companies do, which is we create an identifier at the top level of our API, and then we pass that identifier all the way up and down the stack so that we can pinpoint one flow of traffic for one customer. And the great thing with this logging is it gives us a tool to do sort of rich levels of analysis. So we can sort of really analyze what's going on at the various stacks of our API, and we can carve it up and segment it up. Now, for me, logging in APIs from an author perspective can only be done one way, really, and that's using cloud-based logging services. So, I think we've gone from the days where the Apache log is a flat file dumped onto disk, or a MySQL log is a flat file dumped onto disk, and if we've got 3 or 4 servers, then we've got 3 or 4 files we need to join together, and then we need tools to browse through these files. With cloud-based logging, we've overcome this issue. We're already hosting our servers on services like AWS or Azure, so why not our logs? And there are many cloud-based logging services out there. So my top 3 are sort of Sumo Logic. So Sumo Logic is an enterprise-style real-time searching logging service. It gives you dashboards, monitoring, and alerting. And Logstash. So Logstash is a self-hosted. It's not cloud-hosted. You can host it in the cloud yourself. It's recently become part of the Elasticsearch suite of products under the Apache license. And you can fire this up, you can collect logs, you can parse logs, but you can also pipe those logs onto other services. So you could pipe logs into Redshift or NoSQL solutions. The one we've been using for the last 3 years, so we've been running our main API in production for the last 3 years, and we've been using Loggly. So we've been using Loggly on our hierarchical API to trace all the requests up and down the stack. And we log 3.4 gigabytes of JSON data a day. That's 500,000 requests of payloads of data, and that's just in the short breaks part of our business. If we look at logs across the whole of our business, it's significantly more than that. And the advantages we find with Loggly is that, as you can see here, we can see when it's nighttime and daytime, we can see the volume of requests coming in. This is just the last 24 hours. And we can actually drill down and find individual requests. So what I've done here is I've searched for SGL. Now, SGL is our code for a single room on our API. And what I can see is individual packets of data that have gone backwards and forwards to customers on our API. I can see the trend of single room searches, but I can actually come and segment this data further by availability requests or booking requests for single rooms. So the power here, if a customer rings up our call center and says, I had trouble booking online, or I booked online, but I'm not sure the right amount was taken from my credit card, or I thought I booked for 2 nights, but it's only showing me 1 night on my email. We can come in and we can see every JSON payload that came into our top API, that then went down to further APIs, went off to third-party providers, and all the payloads of data that come back. And as I said, we can segment this data even further. So here I've segmented this data further from single rooms to single rooms by theme park codes. So I can see that Alton Towers, single rooms are more popular than Legoland Windsor or Thorpe Park. So, the power here is endless. And by using cloud-based logging services as an API author, you have great visibility on what's going on in your stack. Now, in the early days, we put all our error reporting into cloud-based logging services as well. So not only did we log the payloads of data going up and down, but we also logged when exceptions happened for us in Node.js. And this was wrong. This was really wrong. It was hard to actually segment the exceptions happening from the logs that were going. And what we really wanted was a service that we could ping when exceptions happen. Now again, luckily we've had a great emergence of tools in this area in recent years. So Bugsnag is a cross-platform, it detects crashes, so they have SDKs in all the top programming languages. You can drop it in a few lines of code. So if you're writing Node.js, you do npm install Bugsnag, and it will give you a Bugsnag interface. And then it just wraps your exception handler. It does the same in Python and Ruby. Airbrake is very similar. And Sentry, again, is a similar product. They all roughly work the same way. They all have various different pricing plans, but all of them give you insights into errors happening within your API, or even non-API code. So here's a small snapshot of our Sentry logs. And then if you drill into one of these, what we actually get, and the power we get here, is that we can actually see the URL that was called by the customer on our API. We can see the method. We can see the query or the post data that was sent up. We can see all the headers. If I scrolled further down, we can see what versions of npm packages we've got installed. We even see which box it occurred on. So if we've got multiple EC2 boxes, we can see which one this occurred on. And we can see the file and the line number that it actually fell over on. So the sort of insight of our data here is great. If we put a new version of our API into production and somebody's made a mistake on one of our lines of code, we very quickly have this bubble up to the top. But this only really works with monitoring. So, we can be logging all these logs into Loggly, or we could be having this error reporting going into Sentry. But unless we're monitoring this stuff, it's not really effective. So we need to pipe all these logs into a monitoring service to really get insight into what's going on. Zapier is a great monitoring service. Zapier it's not their primary product, they do a workflow tool, but they've raised an API recently that follows the top 200 APIs. So they have a dashboard that follows the top 200 APIs, and they show you the uptime and downtime stats on those APIs. So if you think there's a problem with your app that you've written against the Twilio API, you can go on here and see if the Twilio API is up or down, and how long it's been down for. Again, I've mentioned RunScope before. They have a whole suite of tools, but they have a tool called RunScope Radar, which again, you can write effectively unit tests, almost like Selenium tests for your API. So you can define an API endpoint, you can define some data to send it, you can then define an interval in which you want to send that data down, and then what you expect the response to be. And then if that response doesn't match what it expects, then again, it can tell you what's going wrong and tell you an alert. And Duxboards is sort of like a data visualization tool, so this is what we use. We can pump everything from sort of GitHub to Google Analytics to Pingdom to Loggly and start funneling all our various monitoring services into one place so that we can see if things are happening across our stack and if errors are related to one another. Now, although sort of Kirsten picked up on this yesterday, you know, speed isn't everything. The first thing we really want to do is build an API that people want to consume. For others, sometimes speed is an issue. So if you've got your API out there and it is being used, and now you might have a scaling issue. And again, you know, before we have to debug this issue, we can actually use load testing tools to show us what's going on here. So if you want to be optimizing your API for throughput, or you think that you're going to have a scale issue, then we can utilize some of the tools that are out there. So Siege is a great tool. It's sort of come along and filled in behind where Apache Benchmark left off. Siege is a command line tool. It's an HTTP load testing and benchmarking utility. If you want to see how many requests per second you can serve on your website or on your API, then this is a great tool to use. Loader.io works in a similar way, only it's cloud-based, so you don't run it on your own machine. It's a hosted service. And WRK is a modern HTTP benchmarking tool. Again, it's capable of generating significant loads, so you can pretend to be acting like thousands or tens of thousands of people consuming your API, and then see how your API performs. Now, WRK, again, is fairly easy. We can just fire it up with a number of threads, concurrent connections, and a period or duration of time. And then we get deep analytics on the number of throughputs, the latency, etc. So I've covered consumer debugging, and I've covered debugging from the API perspective. And as I said, I've got a bit on the end to talk about author considerations. Now, I won't spend long on this. Most of this was covered yesterday by Kirsten. But, you know, as an API author, we have a responsibility to make the lives easier of those developers that are consuming our APIs. You know, it is our job, as I said earlier, to make sure that they're not, you know, they don't cry. And docs is the sort of fundamental point of this. And I'm not talking about just documenting your API and documenting it well. Docs goes far beyond that. And docs sort of involves putting up getting started guides, putting up websites where you can very quickly send a test request to an API and see how it works. It's writing FAQs, it's answering questions on Stack Overflow, it's building T's and C's, you know. And as has already been mentioned, Twilio are a good example of a company that do docs well on their API. But if you're planning on building a public API and you want it to be adopted, then it really is your responsibility to build a rich suite of docs around that. Now, this was heavily picked up yesterday and also mentioned by David Zuckerman and also mentioned in the opening keynote this morning. But there's a number of API design tools that have emerged. These design tools allow us to document an API, and in documenting it, you know, they fulfill this need. So API Blueprint is based on Markdown. RAML is a sort of RESTful API modeling language based on YAML. And Swagger is the one that keeps coming up over the talks over the last few days, which again uses YAML and allows you to sort of generate a documentation for an API, and then off that you can actually build SDKs. Again, there's a talk in its own right on something like Swagger, but Kin Lane, a great guy talking in the API scene, has done a series of blog posts on this. So he's compared all three, he's documented all three. And if you want to know more about this area, then I strongly encourage you to go and watch his videos or read his blog. Now, I've touched up on this briefly, so I mentioned this recently about SDKs. You know, one of the things that makes me want to use something like AWS or Twilio is that they have SDKs that wrap their API. I don't actually write code to make HTTP requests. I just include, you know, an NPM package to talk to Twilio, and then I call .sms and send an SMS message. You know, if you want your API to be adopted, and if you don't want to be constantly helping your consumers debugging their issues, then if you wrap your API in an SDK, chances are that you'll get over a lot of the auth issues, and you'll get over a lot of the other issues with forming the request over HTTP. And we can't forget about the idea of human help. So when I first ran through this set of slides with my team, they were like, hang on a minute, you know, you've got all these tools, but sometimes you actually want to go and talk to somebody, you know. And for the great, you know, the big APIs out there, we've got things like Stack Overflow, and you can raise GitHub issues, and actually get talking to the guys that have authored these APIs to support you in what you're trying to do. You know, again, the Twilio guys are great at this. They have developer evangelists that are more than willing to understand your use case of their API and help you with what you're trying to achieve. A couple of slides to close on. So although I talk about APIs a lot, I'm by no means an expert. And the guys that I do consider experts are these three here. And if you are authoring an API, then I would follow these guys on Twitter. So Kin Lane is the API evangelist. He's done an excellent series of blog posts about authoring APIs and some of the tools I've mentioned today. John Sheehan is the founder of Runscope, which again is a commercial tool for debugging APIs, but he is very free and willing in sharing information about the API scene. And Kirsten, who spoke yesterday, who I've learnt a lot from seeing at various conferences, mentioning about APIs and the tools that are emerging. And I want to leave you on this thought. So this is a quote from Kin Lane, that API design is often done in the trenches of API operations, iterating and perfecting as an API initiative evolves. So I feel that what he's trying to say here is no matter how much we spend time considering this stuff up front, we're still going to have debugging issues down the road. Our API is going to evolve, its version's going to change, consumers are going to get affected by this. And so we need to constantly be going back and thinking about API debugging and thinking about how we can iterate on these tools and make them better as the future goes on. The future really is about APIs as we move more to mobile and we move more to sort of JavaScript client-side tools like Angular and Backbone. We're consuming APIs more and more. And the tooling's only now catching up with its usage. So that's the end of my talk. Thank you very much. If you have any questions, feel free to hook me up on Twitter. All of the links from my footnotes are available as a bit.ly group. A shameless plug, we are employing at Holiday Extras. We're always looking for great developers. So if you're interested, hit join.holidayextras.co.uk. And I think I've got a bit of time for questions.